You visit your doctor because you're having trouble sleeping, maybe some bladder issues, a little heartburn, or seasonal allergies. Nothing unusual. These are common problems, especially as we get older. Your doctor writes a prescription. You take the medication exactly as directed. Months pass, sometimes years, and then something strange begins to happen. You start forgetting names, misplacing objects, walking into a room and wondering why you went there. At first, you brush it off. Maybe I'm just getting older. But here's the uncomfortable question more scientists are asking today. What if some of the medications meant to help you are quietly harming your brain? Now, let me be very clear. Medications can be life-saving, and many are absolutely necessary. But the reality is that some commonly prescribed drugs can interfere with brain chemistry, blood flow, and cellular energy inside the brain, especially in older adults. Here's what's really going on inside your body. Your brain depends on a delicate network of chemical messengers called neurotransmitters. These chemicals regulate memory, focus, mood, and cognition. One of the most important of these is acetylcholine. Think of acetylcholine like the brain's internal Wi-Fi system. It allows neurons to communicate quickly and efficiently, forming memories and processing information. But certain medications, particularly those with anticholinergic effects, block this signal. Over time, that interference can weaken neural communication. What the research shows is concerning. Large population studies have found that long-term exposure to strong anticholinergic medications is associated with a significantly higher risk of dementia. In fact, many drugs prescribed for everyday issues, including allergies, bladder problems, sleep disorders, and even heartburn, can carry these cognitive effects. Some medications can also affect the brain in other ways. They may reduce blood flow to the brain, disrupt sleep architecture, deplete key nutrients like vitamin B12, increase inflammation or oxidative stress. All of these processes can slowly weaken the brain's resilience. For older adults, the risk becomes even greater because the blood-brain barrier becomes more permeable with age, allowing medications to penetrate the brain more easily. And here's something most people don't realize. Many seniors are taking 5, 10, or even more medications simultaneously, a phenomenon known as polypharmacy. When drugs interact, their cognitive effects can compound. This doesn't mean people should suddenly stop their medications, but it does mean we need to ask better questions. Are these drugs still necessary? Are there safer alternatives? Are there lifestyle or metabolic solutions that address the root cause? In this video, we're going to explore 9 popular medications that research suggests may increase the risk of cognitive decline and dementia when used long-term. More importantly, we'll discuss what's happening physiologically in the brain and what you can do to protect your memory and cognitive longevity. Because dementia isn't just about aging. It's often about metabolism, inflammation, circulation, and brain chemistry. And the more we understand these systems, the more power we have to protect them. If this kind of science-based health information is helpful to you, consider subscribing. I post content like this every day to help people optimize their metabolism, protect their brain, and age with strength and clarity. Let's start with one of the most common medication categories linked to cognitive decline in older adults: first-generation antihistamines. These are drugs many people take for allergies, colds, itching, or even sleep. Examples include medications containing diphenhydramine, which is the active ingredient in many nighttime allergy and sleep aids. You may recognize products like Benadryl or certain PM pain relievers that include this compound. Now, on the surface, antihistamines seem harmless. They reduce allergy symptoms by blocking histamine, a chemical involved in immune responses. But here's what's really going on inside your brain. Many of these older antihistamines cross the blood-brain barrier very easily. Once inside the brain, they block not only histamine receptors, but also acetylcholine receptors. Remember earlier when we talked about acetylcholine as the brain's communication network? When medications block acetylcholine activity, they produce what's known as an anticholinergic effect. Let me explain this with a simple analogy. Imagine your brain as a city filled with millions of tiny highways connecting different neighborhoods. These highways allow messages to travel quickly between neurons so you can remember information, process language, and stay mentally sharp. Acetylcholine is like the traffic system that keeps those highways moving. Anticholinergic medications are essentially roadblocks placed across those highways. Signals slow down. Some never reach their destination. Over time, this communication breakdown can weaken the neural circuits responsible for memory and cognition. What the research shows is striking. A large study published in JAMA Internal Medicine followed nearly 3,500 adults over the age of 65 and found that people who used strong anticholinergic medications for extended periods had a significantly higher risk of developing dementia. Even more concerning, the increased risk was seen with cumulative exposure over several years. In other words, the longer these medications were used, the greater the potential impact on brain health. Now, occasional short-term use may not be a major issue for most people, but daily or long-term use, especially in seniors, raises real concerns. And here's where metabolism also comes into play. As we age, the liver's detoxification capacity slows down and kidney filtration declines. That means medications stay in the body longer, increasing their impact on the brain. At the same time, the blood-brain barrier becomes slightly more permeable with age, allowing more of these compounds to enter brain tissue. So what can you do if you struggle with allergies or sleep? First, consider non-sedating antihistamines, which are less likely to cross into the brain. These newer medications were specifically designed to reduce anticholinergic effects. Second, look at root causes of chronic allergies. Many allergic reactions are tied to inflammation in the gut and immune system. Supporting metabolic health through diet, reducing processed foods, and increasing antioxidant-rich foods can often reduce allergy symptoms naturally. Foods rich in quercetin, for example, such as apples, onions, and berries, have natural antihistamine properties. Third, if sleep is the reason you're using these medications, it's important to address the underlying sleep biology. Instead of sedating the brain chemically, we want to support the body's natural circadian rhythm. That means getting morning sunlight exposure, avoiding bright screens before bedtime, supporting melatonin production with magnesium, and a consistent sleep schedule. Your brain repairs itself during deep sleep. Protecting that process is essential for long-term cognitive health. If this information is helpful so far, consider subscribing. I post content like this every day to help people protect their metabolism, brain function, and longevity naturally. Now let's talk about another major category of medications that many older adults rely on: sleep medications and sedative drugs. At first glance, these medications seem helpful. After all, sleep problems are extremely common with aging. Hormonal shifts, stress, medications, and changes in circadian rhythm can make it harder to fall asleep or stay asleep. So when someone struggles night after night, taking a sleep aid may feel like the obvious solution. But here's what's really going on inside the brain. Many prescription and over-the-counter sleep medications belong to a group called sedative hypnotics, including drugs such as zolpidem, benzodiazepines, and other central nervous system depressants. These medications work by enhancing the activity of a neurotransmitter called GABA, which slows brain activity and produces a calming or sedating effect. In simple terms, they quiet the brain down, but sedation is not the same thing as natural sleep. Let me explain this with a simple analogy. Think of natural sleep as a nightly cleaning crew inside the brain. During deep sleep stages, especially slow wave sleep, the brain activates something called the glymphatic system, a network that flushes metabolic waste products out of brain tissue. One of the substances removed during this nightly cleaning process is beta amyloid, a protein strongly associated with neurodegenerative diseases like Alzheimer's disease. Now here's the problem. Many sleep medications alter the architecture of sleep. They may help you lose consciousness faster, but they often suppress deep restorative sleep phases, which are critical for memory consolidation and toxin clearance. In other words, You may feel like you slept, but your brain didn't fully perform its overnight maintenance. What the research shows is concerning. Studies from researchers at Harvard Medical School have shown that chronic sleep disruption can accelerate the accumulation of amyloid proteins in the brain. Additionally, long-term use of certain sedative medications has been associated with higher rates of cognitive impairment and dementia in older adults. Another issue is that these medications can slow reaction time and impair balance, increasing the risk of nighttime falls, one of the leading causes of injury among seniors. Now, to be clear, there are situations where short-term sleep medications may be appropriate, but relying on them night after night may not be supporting long-term brain health. So what's the alternative? The key is to support the biology of natural sleep. First, focus on circadian rhythm alignment. Your brain regulates sleep through a master clock located in the hypothalamus. This clock responds primarily to light exposure. Morning sunlight signals the brain to start the daytime metabolic cycle, which later allows melatonin to rise naturally at night. Just 10 to 20 minutes of natural sunlight early in the day can help regulate this cycle. Second, stabilize blood sugar metabolism in the evening. Large spikes and crashes in blood sugar can trigger nighttime cortisol release, which disrupts sleep. Eating a balanced dinner that includes protein, healthy fats, and fiber can help stabilize glucose levels overnight. Third, support the body's natural sleep chemistry. Magnesium plays a critical role in relaxing the nervous system and supporting GABA signaling naturally. Many people are deficient in magnesium due to modern diets. Fourth, protect sleep environment quality. This means keeping the bedroom cool and dark, reducing blue light exposure in the evening, avoiding caffeine late in the day, maintaining consistent sleep and wake times. These lifestyle interventions may seem simple, but they work because they support the root biological systems that regulate sleep rather than artificially suppressing brain activity. And protecting sleep quality is one of the most powerful tools we have to protect long-term cognitive function. Next, we're going to look at another widely used class of medications, acid reflux drugs and stomach acid blockers, and why long-term use may quietly affect brain health through nutrient depletion and metabolic changes. Now let's look at another group of medications that millions of older adults take every single day. Acid reflux drugs, particularly proton pump inhibitors, often called PPIs. These medications are widely used to treat heartburn, acid reflux, and conditions like GERD. Common examples include drugs containing omeprazole, esomeprazole, and pantoprazole. For people suffering from frequent reflux, these medications can feel like a miracle. They reduce stomach acid and quickly relieve the burning discomfort many people experience after meals. But here's what's really going on inside your body. Stomach acid is often misunderstood. Many people assume it's something harmful that should be suppressed. In reality, stomach acid plays several critical roles in the body. It helps break down proteins, it activates digestive enzymes, and perhaps most importantly, it allows the body to absorb essential nutrients that the brain depends on. When stomach acid is suppressed for long periods of time, this digestive system begins to malfunction in subtle ways. Let me explain this with a simple analogy. Think of stomach acid as the key that unlocks nutrients from food. Without that key, nutrients remain trapped and can't be fully absorbed. One of the most important nutrients affected by this process is vitamin B12. Vitamin B12 is essential for maintaining the protective coating around nerves known as the myelin sheath. This insulation allows electrical signals to travel efficiently along nerve cells. When B12 levels drop, nerve communication begins to slow down. Symptoms may include memory problems, brain fog, confusion, fatigue, numbness or tingling in the hands and feet. Over time, prolonged B12 deficiency can contribute to neurological damage and cognitive decline. What the research shows is very interesting. Large observational studies have suggested that long-term proton pump inhibitor use may be associated with an increased risk of dementia, possibly due to nutrient depletion and metabolic changes. For example, Research published in JAMA Neurology examined thousands of older adults and found a correlation between prolonged PPI use and higher dementia risk. Now, it's important to emphasize that this type of research shows association, not necessarily direct causation, but the biological mechanisms, particularly nutrient depletion, are well understood. PPIs may also reduce absorption of other nutrients critical for brain and metabolic health, including magnesium, calcium, and iron. Magnesium is especially important because it supports nerve signaling, sleep regulation, and energy production in brain cells. So if someone is taking a PPI for years without monitoring nutrient levels, deficiencies may slowly develop. But here's another layer to this issue. In many cases, acid reflux isn't caused by too much stomach acid. It's caused by metabolic dysfunction and digestive imbalance. For example, excess abdominal fat can increase pressure on the stomach. High sugar diets may promote inflammation and gut dysbiosis. Eating large meals late at night can impair digestion. So instead of only suppressing stomach acid, it can be incredibly helpful to address these underlying drivers. Here are a few strategies that often improve reflux naturally. First, avoid lying down immediately after meals. Giving digestion 2 to 3 hours before bedtime can dramatically reduce nighttime reflux. Second, reduce ultra-processed foods and refined sugars that disrupt gut bacteria and increase inflammation. Third, support digestive function by eating slowly and chewing food thoroughly. Digestion begins in the mouth, and poor chewing can place unnecessary stress on the stomach. Fourth, maintain a healthy weight and support metabolic health, since abdominal pressure plays a major role in reflux symptoms. And finally, if someone does need to remain on acid-suppressing medication long-term, it may be wise to monitor vitamin B12 and magnesium levels periodically. Supporting the body with adequate nutrients can help protect brain function while managing digestive symptoms. If this information is helpful so far, consider subscribing. I post science-based content like this every day to help people protect their metabolism, brain health, and longevity naturally. Next, we'll explore another surprising medication category linked to cognitive decline, certain bladder control medications that many seniors take daily, but that can strongly interfere with brain neurotransmitters. Now, let's talk about another group of medications that many seniors take every day, often without realizing their potential impact on the brain. Bladder control medications used to treat overactive bladder. As we age, changes in muscle tone, hormone levels, and nerve signaling can make bladder control more difficult. This condition, often called overactive bladder, can cause frequent urges to urinate, nighttime bathroom trips, or even leakage. To manage these symptoms, doctors commonly prescribe medications such as oxybutynin, tolterodine, and sulfonacin. These drugs work by relaxing the bladder muscle so it doesn't contract as frequently. On the surface, that sounds helpful, and for many patients, these medications can improve quality of life. But here's what's really going on inside the nervous system. The bladder is controlled by a complex communication network between the brain, spinal cord, and pelvic nerves. One of the key neurotransmitters involved in this signaling system is, once again, acetylcholine. Remember earlier when we discussed acetylcholine as the brain's communication signal for memory and cognition? The medications used to calm the bladder often work by blocking acetylcholine receptors. This helps prevent the bladder muscle from contracting too frequently. But here's the catch. These medications don't only affect the bladder. Because they circulate throughout the body, they can also reach the brain and interfere with acetylcholine signaling there as well. Let me explain this with a simple analogy. Imagine acetylcholine as the telephone system connecting different departments inside a large company. One department controls bladder activity. Another department manages memory and learning in the brain. Bladder medications essentially turn down the volume on the entire phone system to quiet the bladder signals. But when the brain's communication lines are also dampened, cognitive processes can slow down. Over time, this may affect memory formation, focus, and mental clarity. What the research shows is important. Studies have found that certain bladder medications carry some of the strongest anticholinergic effects of any commonly prescribed drugs. Researchers from University of Washington School of Pharmacy conducted studies showing that cumulative exposure to strong anticholinergic medications, including bladder drugs, was associated with a significantly increased risk of dementia later in life. This risk appears to grow with long-term use and higher cumulative doses. And because overactive bladder often develops gradually, many patients remain on these medications for years. Another factor to consider is polypharmacy, which we discussed earlier. A senior may be taking an antihistamine for allergies, a sleep aid at night, and a bladder medication during the day. Each of these medications may carry anticholinergic effects. Individually, the impact might be small, but together they can create a cumulative burden on the brain's neurotransmitter system. So what are the alternatives? In many cases, addressing the root causes of bladder dysfunction can significantly reduce symptoms. For example, metabolic health plays a major role in bladder function. Elevated blood sugar levels can irritate bladder nerves and increase urinary frequency. Stabilizing glucose through balanced meals, reducing refined carbohydrates, and improving insulin sensitivity can sometimes improve bladder control. Pelvic floor strengthening is another powerful strategy. Simple exercises known as Kegel exercises help strengthen the muscles that support bladder control. When practiced consistently, they can significantly reduce urgency and leakage. Hydration patterns also matter. Drinking most fluids earlier in the day and reducing large fluid intake before bedtime can help decrease nighttime bathroom trips. Caffeine and alcohol are also common bladder irritants, and reducing them often improves symptoms. For individuals who still require medication, some newer bladder treatments have lower anticholinergic activity, meaning they may have less impact on brain chemistry. This is an important conversation to have with a healthcare provider, because protecting bladder health should not come at the expense of protecting brain health and cognitive longevity. In the next section, we'll explore another medication category that many people never suspect could affect cognition: certain anti-anxiety medications and benzodiazepines, and why long-term use may interfere with memory formation in the brain. Now let's talk about another group of medications that are widely prescribed, especially among older adults dealing with anxiety, stress, or sleep difficulties: benzodiazepines and certain anti-anxiety medications. These drugs include medications such as diazepam, lorazepam, and alprazolam. For many people, they provide fast relief from anxiety, panic attacks, or insomnia. And in short-term situations, they can be extremely helpful. But the concern arises when these medications are used regularly for months or years, which unfortunately happens quite often. Here's what's really going on inside the brain. Benzodiazepines work by increasing the activity of a neurotransmitter called GABA, which stands for gamma-aminobutyric acid. GABA is essentially the brain's primary calming signal. When GABA activity increases, brain cells fire less frequently. This creates the relaxing, sedating effect that reduces anxiety and helps people fall asleep. Let me explain this with a simple analogy. Imagine the brain as a large orchestra. Every section, memory, attention, emotion, decision-making, is playing its own part to create a balanced performance. GABA acts like the conductor slowing the tempo of the orchestra when things become too intense. Benzodiazepines dramatically amplify that calming signal. The result is that brain activity slows down, anxiety decreases, and the nervous system relaxes. But if the brain remains in that slowed state for long periods, some important cognitive processes begin to suffer. One of those processes is memory formation. The hippocampus, the region of the brain responsible for forming new memories, relies on a precise balance between excitatory and inhibitory signals. When benzodiazepines suppress neural activity too strongly, the hippocampus may have difficulty encoding new information. This is why people taking these medications often report short-term memory problems or difficulty concentrating. And over time, chronic suppression of neural activity may affect brain plasticity, the ability of the brain to adapt and form new neural connections. What the research shows is noteworthy. Several long-term observational studies have found that extended use of benzodiazepines may be associated with an increased risk of cognitive decline and dementia in older adults. Research published in BMJ examined large populations of seniors and found that individuals using benzodiazepines for extended periods had a higher likelihood of developing dementia compared to non-users. Again, these studies show association rather than absolute causation, but the biological mechanisms make sense when we understand how these medications influence brain signaling. Another challenge is tolerance. Over time, the brain adapts to the presence of benzodiazepines, meaning higher doses may be needed to achieve the same calming effect. This can create a cycle where individuals become dependent on the medication for sleep or anxiety relief. So what can we do instead? The key is to address the root physiological drivers of anxiety and sleep disruption. One major factor is chronic stress and cortisol imbalance. Cortisol is the body's primary stress hormone. When cortisol remains elevated due to poor sleep, blood sugar instability, or chronic stress, the nervous system stays in a heightened state of alertness. Supporting metabolic stability can dramatically improve anxiety levels. For example, eating balanced meals that include protein and healthy fats helps stabilize blood sugar and prevent stress hormone spikes. Regular physical activity improves insulin sensitivity and supports neurotransmitter balance. Mindfulness practices, such as breathing exercises or meditation, help regulate the autonomic nervous system. Magnesium is another nutrient worth mentioning. Magnesium supports natural GABA activity in the brain, helping the nervous system relax without suppressing brain function the way sedative drugs do. Foods rich in magnesium include leafy greens, pumpkin seeds, almonds, and dark chocolate. When needed, magnesium glycinate supplements are often used to support relaxation and sleep quality. The goal isn't simply to suppress anxiety, it's to restore balance to the nervous system and metabolism. When the body's biological rhythms are working properly, the brain becomes far more resilient to stress. Now let's examine another medication category that millions of seniors take daily to protect their cardiovascular health: cholesterol-lowering statins. Drugs such as atorvastatin, simvastatin, and rosuvastatin are commonly prescribed to lower LDL cholesterol and reduce the risk of heart attacks and strokes. And to be fair, for people with significant cardiovascular risk, these medications can be extremely beneficial. There is strong evidence that statins can reduce cardiovascular events. But when we talk about brain health, the conversation becomes more nuanced. Here's what's really going on inside your body. Your brain is actually one of the most cholesterol-rich organs in the entire body. In fact, about 25% of the body's cholesterol is found in the brain. This cholesterol isn't the same as the cholesterol circulating in the bloodstream. Inside the brain, cholesterol plays essential structural roles. It helps build cell membranes, synapses, and myelin sheaths, which insulate nerve fibers and allow electrical signals to travel efficiently. Think of cholesterol as one of the building materials for brain cells. Now, statins work by blocking an enzyme in the liver called HMG-CoA reductase, which reduces the body's production of cholesterol. This process is extremely effective for lowering blood cholesterol levels. But cholesterol production is also connected to other biochemical pathways that the brain relies on. One important example is coenzyme Q10, often called